Hello dear students, as you all know we are doing chapter number 9 ray optics in the YouTube video lecture series. Although we have completed it long time ago, and wave optics we have completed wave optics chapter number 1 and chapter number 2 is going on. But for the backup videos, for the sake of revision and for the students who have taken admission late, we are making YouTube videos. So in that series, in YouTube series, we have done 14 part of the ray optics. Today is the 15th part, and today the last segment of the chapter is going to be started, and the last segment is optical instruments. Last segment of ray optics is optical instruments. In optical instruments, mainly we have to discuss simple microscope, compound microscope and telescope. But before discussing all of them, there are few terms which we need to know to understand them in a better way. So let us discuss first of all those terms, and then after we'll come to simple microscope, compound microscope or telescope. Okay, so let us discuss those points. The first point we need to understand is visual angle. Visual angle. What is visual angle? Suppose if there is an object in front of our eye, this is our eye. So this object must be making some angle to our eye. This object subtend some angle to our eye, and this angle is called visual angle. Visual angle subtended by this object AB at our eye. Okay, so visual angle subtended by an object to our eye is called, the angle subtended by an object to our eye is called visual angle. Now this visual angle for the same object, if the distance varies, suppose the object AB is here, after some time the object AB come over here, means at a nearer point to eye, then what will happen? The visual angle increases. And if the same object goes far away from eye, then the same angle decreases. So visual angle depends on the distance of the eye and the object also. I hope I am clear. Okay, so visual angle is the angle subtended by an object to our eye. Now for our eye, on an average we say that, because for different person it is different, but on an average we say that 25 centimeter is the least distance of distinct vision. Capital D is equal to 25 centimeter. What this is called? This is called least distance of distinct vision. Although this least distance is different for different person. On an average, for calculation, we take it 25 centimeter. Is it clear? So 25 centimeter is least distance of distinct vision. So this is also our near point. Before this point, if an object is kept closer to 25 centimeter, more nearer to 25 centimeter, I mean to say that if the distance between eye and the object is less than 25 centimeter, as per the physics calculation, we will not be able to see that. Okay, as per the physics, whatever the average we have taken is 25 centimeters. So below this distance, if an object is kept at, so we will not be able to see that object. So this is called least distance of distinct vision. So visual angle, since for different distances it is different. So visual angle, we always consider the angle which is made at a distance 25 centimeter to our eye. So this is the visual angle subtended by an object. So the distance between the object and the eye, this position is eye and this position is object. The distance between them must be what? Least distance must be them what? 25 centimeters. It cannot be less than that. Okay, and the maximum distance is infinity, because our far point is at infinite. So I hope I am clear with visual angle. Now the second thing you need to understand is magnifying power. Magnifying power. What is magnifying power? So it is defined for all the instruments, optical instruments, and basically magnifying power capital M is defined as visual angle subtended by image upon visual angle subtended by an object. So visual angle subtended by an image upon visual angle subtended by an object. So this is the definition of magnifying power. We need to understand that the position of image and the position of object is different. For different position of image, this magnifying power will be different. For different position of object, this magnifying power will be different. So what we do, we try to calculate magnifying power for standard cases only. So there are two standard cases. When the final image is formed at capital D, that is the least distance of distinct vision, and when the final image is formed at infinity. So visual angle subtended by the image formed at infinity or capital D. If it is infinity, then corresponding visual angle of object is taken. If it is at D, then also visual angle of object is taken. Object has to be kept at 25 centimeter. For simple microscope, compound microscope, object is always at 25 centimeter. For telescope, since telescope is used to view far distant objects, so for them visual angle is for the object is the object if the object is placed at infinity. So capital M is defined as visual angle subtended by the image given by beta and visual angle subtended by the object given by alpha. So capital M is equal to beta upon alpha. These two definitions must be clear to everyone. Visual angle, what is visual angle? Angle subtended by an object to our eye. And what is magnifying power? Ratio of visual angle subtended by the image to the visual angle subtended by the object. So now we are ready to understand optical instruments. Let us start optical instrument. And the first optical instrument we are going to do is simple microscope. The first optical instrument we are going to study is simple microscope. I hope you must have seen one instrument which is generally at our places at our home also, and it is with the doctors, it is with the person who repair watch or mobile. You must have seen magnifying glass. So magnifying glass is what? A simple convex lens is there, biconvex lens provided with a handle. So this is what the simple microscope is. Simple microscope is simply a convex lens, double convex lens provided with a handle. Its focal length is kept short, and as per the requirement, its aperture is kept. If the image has to be seen is very small, aperture should be very large. If the image have to be seen of the object have to be seen through the microscope is not that small, so aperture can be smaller also. So a simple magnifying glass is what? A simple microscope. It is a biconvex lens of short focal length provided with a handle. Now there are two cases for simple microscope, and from those two cases only I'll explain the principle of simple microscope. First case is when the final image is formed at capital D. I hope you remember capital D. Just a few minutes before we have discussed that capital D is the least distance of distinct vision. For the sake of calculation, it is considered to be 25 centimeter, but in practical aspects for different person, the visual angle is this least distance is different. Okay. So how the setup is there? A simple microscope, simply a convex lens, and what is done if it is focus is this. So an object is kept between the focus and the optical center. So all we know what will happen. One ray passes through the optical center and it passes undeviated. The another ray passes through the principal axis. Okay, and if the extended ray is like this, then this is the focus. So what is happening? They are going like that. If we extend them behind, we'll have an image over here. So if the object is A, comma B, then the image is A dash, B dash. The rays have to be extended behind to get the image. The position of object is set such that the distance between the image and the optical center is capital D. Okay. So principle of the simple microscope is this only. The object is kept between focus and the optical center, and its virtual magnified image is formed behind the object. The position of object is set such that the position of the object is taken such that the image is formed at the least distance of distinct vision from the optical center. Now for all the optical instruments we need to calculate magnifying power also. So let us calculate magnifying power of the simple microscope. For magnifying power we need two things. One, visual angle subtended by the image. Another one, visual angle subtended by the object, because the ratio of visual angle subtended by the image to the visual angle subtended by the object is defined as the magnifying power. So basically what is the visual angle subtended by the image over here? So just see this angle. If our position of eye is this one, so this angle is the angle subtended by the image to our eye. So this angle is beta. This is considered as visual angle subtended by the image. For visual angle subtended by the object, what we do? We make object in a different diagram, put our eyes over here, say this is capital E, this is the position of our eye, and this is the object AB. So object AB subtends an angle alpha. So visual angle subtended by the image is beta, visual angle subtended by the object is alpha. So magnifying power is defined as beta upon alpha. We'll mention that where the image is formed and where the object is taken. Image is formed at capital D, object is taken at capital D. We have to mention that also. Okay. Then the first line we should have written that M is equal to visual angle subtended by the image formed at capital D upon visual angle subtended by the object placed at capital D. So, but for the sake of place it is not there, so I have not written, I have just written beta upon alpha, and the figure it is clear that what is beta, what is alpha. So M is equal to beta upon alpha, value of beta. Now this beta and alpha, they are very smaller angles. Throughout the optical instrument, throughout the ray optics, we have discussed that these angles have to be very small because we are discussing first order optics. So all the angles, beta, alpha, incidence, refraction, all the angles are considered to be very small. So basically beta upon alpha can be equal to tan beta upon tan alpha, because if an angle is smaller, then we can write theta is equal, tan theta is approximately equal to theta. So now tan beta. If you see this diagram, so tan beta is there in two triangles. One is ABO, another one is A dash B dash O. You can take whatever triangle you like. From both the triangle it can be proved. I am taking the smaller one, AB upon OA. So tan beta will be equal to AB upon OA, whereas tan alpha is equal to AB upon EA. AB upon EA. Now let us put the values to get what is there. So if I put the value of AB, let the height of the object be h. OA is object distance and it has to be negative. OA, object distance negative. I have written E because of IPs. We have kept our eyes over here, that's why. AB is h and what is EA? It is D. So h and h will be cancelled out. D should also be minus because from E to A we are going. So which is opposite to the direction of incidence of light. So h and h will be cancelled out, minus and minus will be cancelled out, m comes out to be D upon UE. This is the general formula for magnifying power for a lens. For a lens, it is a general formula. If the final image is formed at capital D, this is the general formula for magnifying power. Okay, now we have to put the value of 1 upon UE over here. How we can? From lens formula, 1 upon F is equal to 1 upon minus D minus 1 upon minus UE. I hope you remember 1 upon F is equal to 1 upon V minus 1 upon U. So in place of V I have written minus D, image distance. In place of U I have written UE. This is minus UE. Sorry, OA is minus UE. So this is minus UE. Now 1 upon UE we need to know. So minus minus will become plus. So 1 upon UE comes out to be 1 upon F, and this goes this side, so it will become 1 upon D. So 1 upon UE is put over there. So we'll have capital M is equal to D in bracket 1 upon F plus 1 upon D. If D is multiplied inside, we'll have M is equal to D upon F plus 1. So this is the formula. This is not there in the frame. Let me write it here. So if D is multiplied over here, so M is equal to 1 plus D upon F. This is the formula for magnifying power if the final image is formed at capital D. This is very easy. And simple microscope has been asked in the board examination so many times. So many times it has been asked, and it is very easy also. I hope there is no problem. Only the thing is, if the ray diagram is clear, all the derivations will be clear. If you are missing with the ray diagram, if you are mixing all the things, intermixing the positions, angles, you have not made the angle correct, you will not be able to derive also. Is it clear? And ray optics is there in term 2 also. Split up syllabus is there now. So in ray optics, derivations will be asked. Very important derivation. I hope it is clear. Take this screenshot in case you want to make the notes. Now let us take the case number 2 when the final image is formed at infinity. Now the case number 2 when the final image is formed at infinity. Now if we want that the image should be formed at infinity, then what arrangement we have to make? Just see, this is your optical center. This is a focus. This time the object is kept at focus only. So from focus, one ray through the optical center, another ray parallel to the principal axis, goes like this. Now these two rays which are refracted from the lens, they are parallel to each other. So the final image will be at infinity. This time the object AB, for visual angle of AB, again it is kept at D. This is our eyes. This is object AB. Visual angle of object alpha is given by this only. And visual angle of image, if I put our eyes over here, so this is a visual angle of image. Now just see, If we have to calculate magnifying power, I hope till here there will be no change. All the derivations will remain same. That's why I have not removed it. Just see, every variable, even a, b, everything will same. Only one thing will be changed now, and that distance is ue. OA, this time this object distance is actually equal to focal length of the lens, and only that thing will be changed. And that's why I have told you that this is the general formula for magnifying power of a single lens. So in place of UE, you need to put F. So M is equal to D by F. In case if the final image is formed at infinity, the magnifying power is given by D by F. All the other variables, just match it, it will remain same. All the derivation, beta upon alpha approximately equal to tan beta upon tan alpha, AB upon OA, AB upon OA, AB upon EA, AB upon EA, values, everything will remain same. The thing is, only in place of UE we need to put F. Okay, so this was all about magnifying power, and from the formula of magnifying power we can also explain that why the focal length of the simple microscope lens is taken short, because as F is less, magnifying power is more. From here, one more question: why F cannot be greater than D? If F is greater than D, magnifying power will be less than 1. Okay. Another thing, this case, when the final image is formed at infinity, this is also called relaxed condition of eye, relaxed position of the eye. It is also called relaxed condition of eye or relaxed position of eye. Okay. So this was all about simple microscope. Simple microscope use, as far as use is concerned, so simple microscope is used to view the images of very tiny objects. Okay, small letters. These kind of uses are there for simple microscope. Okay, so this is all for the day. In the next video lecture, we will study about compound microscope, and after that, one more lecture or two more lecture for telescope. So I think 4 or 5 lectures are there to complete this chapter. Then after we start the next chapter. This is all for the day. Thank you.